Hello, this video will be about Hermeticism and how sites such as the Royal Observatory in Greenwich in London, as well as Parramatta Observatory and the Marulan Meridian Arch in Australia, are part of an ancient Hermetic legacy. The wisdom of Thoth or Hermes and the incredible knowledge embodied in the Great Pyramid of Giza being key to this understanding. So we're going to have time, geometry, astronomy, navigation, survey, and the all-important weights and measures, which unifies these things. Now, these ancient arts are still with us today, and they are at least as important now as they were in the ancient past. So I hope you enjoyed. We're going to be focusing on England, with lots of links to Australia, and again the Hermetic principles of as above, so below, how these are incorporated, of course, in the Great Pyramid. And especially through number and measurement, we can observe these things, we can test them. Now, I cannot say with absolute certainty of the passage of how they were passed on, but however, they were real, they are real, and well, they still exist with us today. So anyway, I hope you enjoyed, and here's the video. So as we move, Australia will be a big portion of this, but importantly how it connects to London and specifically the Royal Observatory at Greenwich, which is realise it or not, it's an essential part of the world code still now, whether it's time or navigation. This particular building and these designed by Christopher Wren, no less, very important figure. He also was the architect for St. Paul's in London as well, very important. But here in the Greenwich Observatory, this will be the link which will join us to the ancient world as well as to Australia. So here we are at the Royal Observatory in Greenwich, London, the building designed by Christopher Wren from the era of Hermeticism, essentially, and the building itself still very important as scientifically speaking in the modern sense of the word, but it's also a very hermetic site for many reasons. Now, if we here we have a conversion point, so we see feet, yards, and inches, and of course Hermes, Hermeticism, or Hermes to the Greeks, Mercury to the Romans, was the god of weights and measures, and we see here essentially this is a sacred artifact in a way. Now, not in the sense that most people would think, but it's very hermetic in that sense. It's a conversion stone. It's about law, the law of trade and the law of land division, taxes, all these the foundation stones of our civilization, and any civilization is pretty much written in an object like this. It's you cannot underestimate the value of these things. Thoth, the Egyptian god of weights and measures, as well as Hermes and Mercury, were the gods also of knowledge, of engineering, of technology in that sense as well. So the ancient sciences were built around Hermeticism, and the Hermeticists of the 15th, 16th century, who were the architects of pretty much our modern world, including encoding measurements such as this, were Hermeticists. That's even on the record. It's not well liked, like the fact that Isaac Newton was a Hermeticist, an alchemist. That's tended to be frowned upon if it's not talked very much about. But our world, our modern world, our sciences were born from Hermeticism, from these older streams of knowledge, weights and measures being essential to it. Siena Cathedral, we even have a Catholic cathedral, so going back. But what do we have on the floor? We have Hermes, Mercurius, they got Trismegistus, but Trismegistus, Hermes for thrice, 3 times great. Hermes, Mercury, and and Hermes Trismegistus is essentially a fusion of Hermes and Thoth, and of course Mercury, god of science, of knowledge, and essentially weights and measures. But Hermes was also, or Mercury, now the Roman version has him wearing this helmet thing. The older Greek versions will have him wearing a broad-brimmed hat, or the traveler's hat, which is, again, so often confused, connected to Satanism and all these type of stuff. But anyway, Hermes, Mercury, was also the god of travelers, but also the god of commerce. And what do merchants do? They travel. and very engaged in weights and measures. That's one of the essences of commerce, and of course navigation being so important to that. And when it comes to navigation, the prime meridian, which runs through Greenwich, is essential. It's the 0 point. But navigation also incorporates geometry, time, and direction. So geometry, the compass and straight edge; time, the clock or the pendulum; and direction, the compass. So we're also asking the questions with time, like when am I, when will I get there, through navigation, but also through direction. Where am I going, when will I get there? These, which are also very philosophical questions. Essentially at the heart of religion is, who am I, where did I come from, am I going? In that sense, navigation is very close to the philosophy, which is at the core of religious philosophy and thinking, the big questions in life. So Greenwich Observatory, it's a centre of time and navigation, because the prime meridian is also the 0 hour point. And so weights and measures, time, navigation. Greenwich is a ground zero in the sense for these things. Also has a sundial. We'll get to that in a moment. But for both time and mapping, the Greenwich Meridian is the 0 point. So 0 hours is Greenwich Universal Time, but also for mapping at 0 degrees. 0 degrees, 0 hours runs right through Greenwich. Again, so when it comes to navigation, so the marine chronometer, at least in modern times, that could be a whole long video about working out longitude, how far east or west you are of a certain point. But John Harrison's marine chronometer was an essential tool in the modern era in finding this out. So for instance, if you had an accurate clock on your ship, if you knew what the time was at Greenwich, you could then observe noon where you are and then check it against the clock which was set to Greenwich, and okay, I'm this many hours, it's noon here, but it's 8 o'clock in Greenwich, therefore I know how far east or west I am from Greenwich. And so navigation become very accurate. Now again, that's a whole thing, because there are other methods, but that's something else. But of course this is essential also in survey. So it's not just about navigation by sea or even by land, but it also serves as a 0 point for survey. So when you're mapping roads, when designing roads, placing them, you need to know where you are, where you're going. Also for land survey, so blocks of land, even large tracts of land, you need to know essentially where you are, and then you can work out, you can divide up the land. And survey is also essential in building temples, cathedrals, because you want to, before you lay a block, you want your temple aligned. Ceremonially, this goes back even to ancient Egyptian times. There's lots of temples, and they even have the queen and the king holding 2 sticks with a rope around it, defining the axis. But anyway, that's very important, is survey for so many, just like navigation by sea or navigation by land, survey is essential, but it's also very much connected to Hermeticism. This is a drawing of young George Washington. He was, strongly into survey. Washington DC, the geometry and all that connected to it is absolute evidence of that. In Australia, we'll be looking at Australia, Governor Macquarie was also a conscientious Freemason, as they say, not just a social member, so to speak, but very involved in the craft, just like George Washington, and they shared a lot, including social reform, but they're also very keen on town planning, surveying, and the Hermetic arts. So, which brings us to Parramatta Observatory here in Sydney, which is called the Greenwich of the Southern Hemisphere. And so we have Royal Greenwich Observatory there in London. And if we go to, if my computer will play ball, but we also have Parramatta Observatory in Sydney. Sydney was the first town founded in Australia in the colonial era. Later that same year, in 1788, November that year, Parramatta was founded. So it was the second town in Australia, but also essentially it was the town because the governor had his house there. And okay, my Parramatta Observatory. The observatory at Parramatta, which was the second town founded in Australia, one of those, it's a very important historical site, but maybe not very well known, not very well respected. But it's important for a number of reasons, and especially to do well with, again, weights, measures, mapping, astronomy, geometry, and all these things that go with basically what's around the Hermetic schools, let's say. It's so interesting because it was described as the Greenwich of the Southern Hemisphere, so it connects to Greenwich Observatory in that way. The Greenwich of the Southern Hemisphere, said Governor Brisbane of the Parramatta Observatory, built at his own expense in 1822. Well, it was an observatory, but this was very important in firstly finding the location, the longitude and latitude of Parramatta, and from there, and this little copper marking there is basically the 0 point from which all maps and measurements were into for the colony, for young Australia at the time. So it serves, through astronomy we get a survey point, and just like famously George Washington or Governor Lachlan Macquarie here in Australia, Freemasons, but also very much into town planning, survey, and well, which has to do a lot with measuring length, but of course with once you have that exact longitude and latitude, you also have an exact positioning of time, so you know your time in relation to Greenwich Observatory, which was so important in navigation. Knowing the time was to know how far east or west you were was essential, the marine chronometer being one of the reasons for this. Now there are other methods suggested for it, but yeah, this observatory, even the obelisk, would serve as a sundial in a type of way. But very small site, not glamorous, but still very important in the history of Australia, and connects to the Greenwich Observatory in London. Okay, before we leave, we'll be coming back to Australia. But so we have Parramatta Observatory here to the west of Sydney, and slow connection at the moment, but as we zoom out we get the map of Australia, and this is another interesting thing worth mentioning as well. So we have Parramatta Observatory, and we've already seen how Greenwich is so important to navigation, but that will also have to do with mapping. But bring up, okay, Mathew Flinders. So we have Australia, and we look at we look at Mathew Flinders, and the first map. How did Australia get its name? What was the first very, very accurate map of Australia? And so here we have Mathew Flinders, his statue on the outside the State Library here, New South Wales State Library here in Sydney, and this is his map of Australia, the general chart of Terra Australis, for southern land or Australia. So he was actually the first to write down Australia as a name. It was Governor Lachlan Macquarie in official dispatches that gave Australia its name. It was New South Wales before. Over here we see New Holland. But an interesting feature about this map is, well, firstly, Mathew Flinders was the grandfather or great-grandfather of Mathew Flinders Petrie, the celebrated archaeologist. Now, Mathew Flinders Petrie was an excellent surveyor, and so, for instance, just before he left for Egypt, he did the first very accurate survey of Stonehenge and several other sites. But what's more important about Mathew Flinders Petrie is his work in Egypt. And, for instance, he did the first super duper accurate survey of the Great Pyramid internally and externally. Basically, his work is the go-to still to this day. It's the technology has slightly improved, but the work of Mathew Flinders Petrie was awesome. It's also worth noting that by his study of pottery and other pieces, he would put the officially, the official history says the Great Pyramid especially, was built 2500 BC in the Old Kingdom era. He would put that back around about 1,000 years or even more. So the date that we have now still up for debate, but based on the work of Mathew Flinders Petrie, and some other people to push it back even more. Now, still, some would say, I'd tend to agree that it's actually, at least the Great Pyramids themselves are much older than that. The erosion at the Sphinx, for instance, points to the Sphinx being much older, but that the Sphinx is very old, does just because the pyramid is next to it does not necessarily automatically mean the pyramid is of the same age. But that's just to the side there. But again, this should still really be open. There's a lot of some extremes from one side, but the so-called official dating, well, there's question marks still amongst that. But what's the issue here is the map of Mathew Flinders Petrie, and it's worth noting, well, if you take note, so we see these horizontal and vertical lines, longitude and latitude as we measure them now. We also see these rays which come off there. Now they're an important feature. So the Greenwich Meridian, and we see how it's cut up horizontally and vertically. There we see these lines on the map of Mathew Flinders. But if we compare it to this famous, amongst many others, these very famous old maps, so 1513, we see some the coast of South America there, the Piri Reis map. There is even some older maps which have the Antarctica, the coastline, done with a high precision of accuracy, even though it was under ice. So it's really some strange things in the recorded history and what the official history will tell you. But this famous Piri Reis map, and what do we have? We have these rosettes, roses, compass roses they're called. We don't have the horizontal and vertical lines. What we have is these rose points which point out. This is as it's called, Portolan mapping, this older system of mapping. And so you can see I've highlighted the rays which point out there. Well, so that's another Portolan map. And again, we have the same thing where there's from a central point there are 32 rays heading outwards. So 32 directions from the 33rd point. This is a different type, an older type of mapping and navigation. Now, it's not just about mapping. You'll also see it in cathedrals, major public buildings, esoteric, hermetic buildings. For instance, St. Paul's in London, on the floor there, we have this 32 rays from the 33rd core point. St. Mary's Cathedral, we could pick so many other cathedrals, but again, we have the same thing happening here, where it's being divided up into 32 points around the central 33rd point. The UN map's another example, same thing, but instead of the lines we have sectors. So we have a 33rd round core point, then you have all these other, so 32 of these segments, so 32 around the central 33rd. Weights and measures, and also in some, so for instance 5,280 feet per mile, done some videos on the history of that. But also, so 32 rods, and a rod is an important measure, 16.5 feet. 2 rods is 33 feet, but 32 of those is 528 feet. 33 pounds is 528 ounces, so 32 and 33 coming, and especially connected to 528. Well, the 32nd triangular number, or Pythagorean number, Tetractys number, is 528 as well. So we have these connections that go on. The US dollar, 32 feathers on one side, 33 on the other, is 32 over 33. That's two-dimensional, but it also happens in the three-dimensional. So to make a soccer ball, to get these panels, to get all these shapes to perfectly fit together, you need a series of hexagons and pentagons, 32 panels to be precise, or 32 around a 33rd central point once again. So it works in 3 dimensions as well. So back to the Mathew Flinders map. So not only do we have the modern longitude and latitude and this compass, so I've just cut that out and placed it here, and all I've highlighted it there. So we see the same thing, 32 around the 33rd. Now it's interesting that these hubs are also located on the where these two where the vertical and horizontal meet seems to be centers of there as well. So this was at a time when we were moving from one form to another, and I think this is a good, important document in that sense, because it shows the transition and also gives some idea of how this mapping system works in a very easy to see way, and how they were doing it in the past, and possibly it might be a superior system. That's something else. Mathew Flinders Petrie statue, State Library of New South Wales, on the floor there by the famous family who did some excellent these terrazzo floors all around Sydney. Had the pleasure of meeting the grandson of one of them. He took us on a tour through the crypt of St Mary's, and yeah, some excellent craftsmen, real they were true craftsmen. But this is the Tasman map, and we see this is the early map of Australia before the east coast had been properly mapped, and they still thought Tasmania was connected to the mainland, and that the mainland was connected to Timor, like up to Papua New Guinea, Timor, and the Indonesian islands up there. But we see the compass rose there as well, and there's also some other, like, well, a cross staff. There's a sphere there. Again, this map has there's also a legend as well. Again, we see but weights and measures connected to navigation, to map making, very essential areas like the compass, and we see the ruler, so just to give us measurements as well. So again, this 32 over the 33rd point. So that's another point of interest here in Australia. So back to Australia, staying in Australia, the Parramatta Observatory, the Greenwich of the Southern Hemisphere, this small copper marker being so important to not just Australia. But once this point was established, it went into the gazettes and almanacs, and surveyors much wider than Australia in the Pacific and elsewhere would start using this particular marker, for not just survey navigation, but of course connections to time. All this, of course, relates to Greenwich, and we have the Meridian marker in Greenwich, and this, the line here on the floor. However, this marker is not actually exactly on the Meridian, and I'll put a link in the description. I did a video a while back about moving the markers, and so, for instance, this obelisk here in Sydney was set up by Governor Macquarie, and that was the original 0 point, the milestone from which all roads were moved. But it was moved by a very small distance, and in this video I show how others have been moved, and for unusual reasons, some patently false reasons. But anyway, it's a curiosity that these markers have been moved that are not on the exact spot, and it's just, it's a bit strange to me. I think it points at something else. But so back to Greenwich. It's of course weights and measures, time and navigation. We also have the Greenwich Park sundial, and 32 points mentioned about those rays. Now this compass rose as well, so we see how that is again just this same theme, crossing mapping, geometry, and so many other features as well. But some other famous 0 points, as they're called, so the 0 mile marker out the front. So this is the back, but if you stand just in the front of these two towers, there's this marker, which is, so all the roads were defined from this point. This was like the central survey point. And going back to the golden milestone in the Roman Forum, so all roads lead to Rome, and this essentially was the 0 point from which all the roads were measured. The Roman roads were legendary, and the accuracy in it, and they knew the exact measurements of it. They could work out how much a legion could march per day. Their roads were very straight, and again, very important for working out trade, how to move your troops, these types of things. Interesting to note, for those in the know, you see these patterns here, and that's the Temple of Antonius and Faustina. I covered that in the griffins, and well, again, apart from the griffins, what do we have? We have this same thing, and even you get a bit of a peak. What's growing there? Anyway, that's a separate topic. But back here in Australia, the Meridian marker in Marulan, and we'll see if Google Earth will play ball. Okay, so we have the Marulan marker. Now, of course, this all connects to time and mapping, and Greenwich being the 0 point. We saw those others in at Notre Dame and in the Roman Forum. Okay, my Google isn't playing ball with me at the moment. But so we have the Meridian marker to the south and slightly west of Sydney. And this is how the marker looks from the side, the Meridian marker. Now it's the Marulan Meridian Arch, and it's in Meridian Park, and we have a sundial there as well. And this marker is exactly on the 150th meridian, so 30 degrees from the anti-meridian, the 180th. And Marulan is important because this 150th meridian is the point from which Australian Eastern Standard Time is measured. And this is, well, again, very important feature. So go back to Greenwich, it's the 0 point for measuring time. It's also, we have that sundial here in Greenwich Park, and we have the same in Marulan Grold, along with me, the best is yet to be. There we have Kronos or Saturn holding the scythe. Sundials are, not just a garden ornament. You'll find them in very special parks and very special locations. They're always something to pay attention to. So yeah, the center of this arch is exactly on the 150th meridian, 34.716 degrees south. And as well, what do we have? We have a crescent of the moon, the sun, and here we have a sphere which is broken up into 12 sections, 30 degrees, which is an important connection. We'll get back to that. So we have 30 degrees. There we see the sphere and how it's dividing up into sections of 30 degrees. We'll come back to that later. So the meridian marker at Marulan, but also this connects to 30 degrees, connects to time and pendulums, which brings us back to Greenwich, and this, how the length of a pendulum and the number of vibrations, how many times it swings from one side to the other. It's also worth noting, so we see the weight of 100 pounds in different latitudes. So as you move north or south of the equator, because of the spin of the Earth, and which affects the way gravity, so without going into, but 100 pounds actually weighs different weights at different places on the Earth. This also is important in regards to a pendulum. So that's why these old pendulum clocks, because when you have a pendulum, you can be sure on the swing, the length of the pendulum in relation to the center of gravity will give you a constant time. It's very important. Now, that the Royal Observatory at Greenwich, this is from the Encyclopedia or Universal Dictionary by Abraham Reis, 1812. And what do we have here at Greenwich at 51, 28, 40 degrees? The pendulum using this meter. Now, there's very slight variations on the meter, but what we have is that the pendulum at Greenwich swings exactly 86,400 times per day. Now, that's 864 is a lovely number, but 86,400 seconds per day, and it's a lovely connection to the pyramid. Now, you'll so often see reference that the Great Pyramid is scaled to the Earth at 43,200. Well, it's scaled to half the Earth at 43,200. It relies on a bit of, you have to take two separate views. Okay, that's separate. I'll come back to that later. But what's also interesting about Greenwich is, so if we place the Great Pyramid plan here against, using that, so imagine this is the center of the Earth. Well, 51 degrees and 51 minutes. Greenwich is at 51 and 28 minutes. So very, very close to that position of the Great Pyramid as well. Now, what you'll find along between 51 and 52 degrees is quite a cluster of places. Okay, so Great Pyramid. So, for instance, Stonehenge is at 51.10. And what you'll also find, so here we see, so there's London and this line running across. It also runs through Astana, but the Etonium, several henges are along this point as well. Castle in Germany and Astana. Astana is the equivalent of Washington in that part of the world. It's a major regional capital, just like Canberra, Brasilia, and Washington. Astana is a very special city. Also, if you divide, say, the seven-pointed star, the heptagram, that's 51.42 degrees. So about 51 degrees and 28 minutes. So again, these angles, there's a whole bunch of lovely stuff along this particular 51st parallel, especially in the northern hemisphere. So Greenwich, it's a 0 point for navigation, for mapping, and for time, just like Marulan. Okay, but what's being noted about the pyramid back to Piazzi and Smythe. Well, it seems to be in the center. Now, you might notice this map's a little bit wonky. I'll just use this one because it's a historical one. But essentially, the Great Pyramid it could be said to be in the center of the Earth, in that the east to west of the longest line, sort of east to west and north to south. Now, you could draw a longer line east to west, so if you include it there, but also when it incorporates the north and the south, the Great Pyramid is essentially in the dead center of Africa, Europe, and Asia. The big landmass, which we separate into continents, but it's one connected landmass. The Great Pyramid is in essentially the dead center of it. It's at 29 degrees 58 minutes north, 31 degrees and 8 minutes east of Greenwich. There we see the zero line, the meridian. Now, this course, because it connects to navigation and to time, but the pyramid itself is something of a beautifully positioned in terms of navigation. So, for instance, the location of a pyramid north of the equator is also where the trade winds shift. So if you're sailing, you want to know this position because you can sail a little bit north and the winds will help you move westerly, or they'll help you move easterly. So that's now also the alignments of the shafts, which point to Sirius, which so many cultures across the world, across time, Sirius is a key navigation point. It also points to Alnitak in Orion, another one of these very important, bright stars. Even when there's a haze, Sirius and Orion, as long with the Pleiades, are these stars that you can always see, even in the city at night time. As long as you're not directly under a light, even with light pollution, Orion, Sirius, the Pleiades are these stars, again, for just key for navigation. Now, also on the other side, on the north side, the two shafts track the movement of the North Star as it moves, because of precession. The north is moving all the time. Currently, it's the pole star is there, but this was tracking them going through centuries. Now, because of politics, I suppose you would say. This is an important. Now, this does track those through, but because this points to essentially from 2000, really it's from 4000 to about 1500 BC, it's tracking the North Star. Some people will use that to put a date on the construction of a pyramid. I don't think that that's necessarily, that one doesn't necessarily mean the other. It could be other things, but because it's pointing at this date which doesn't fit certain other things, that there's a few, apparent debunking ones which point this out, but you're sort of throwing the baby out with the bathwater because of this connection to Sirius, the star of Isis, as well, and that even in the pyramid text about the pharaoh going to Orion. So if you want to dismiss these North Star ones, you also really have to dismiss these ones, and these alignments to Orion and to Sirius fit the Egyptian story, basically the Book of the Dead, especially the pharaohs moving through. And however, because it's a dating issue on this, there's certain elements which are, they don't like it, and but anyway, some of the debunking in regards to these alignments is, well, quite flawed as well. But navigation, once again, and this, why am I mentioning the pyramid? Well, we'll see that as well, because the Great Pyramid at 30 degrees north. Now, the pyramid itself is 29.9 degrees north, if you're to use a GPS. However, there are other features in there, such as the way the atmosphere distorts things. Anyway, but even using modern GPS, the Great Pyramids are aligned to Heliopolis. This has been shown to be true. Time Scanners, excellent series going through these ancient sites using best 3D laser surveys and etc., found that actually they are pointing at Heliopolis. Heliopolis is 30 degrees north, or 108,000 seconds, or 0.5236 radian, 30 degrees. Now that brings us back to the pendulum. I'd mentioned the importance of time and the pendulum, and how that connects to, well, the Great Pyramid being a scale model of the whole Earth at 86,400, as in 86,400 seconds per day, pendulums and timekeeping going back a while. Now that brings us back to the importance of the positioning there. So that's 30 degrees north of the equator. Our pendulums, because of the ease of the geometry, but for other reasons as well, they're swung at 30 degrees. Well, a 1 meter pendulum, if you swing that section of arc, that curved part of 30 degrees, 0.5236 radian, or 0.5236 meters, which is 1 Egyptian royal cubit. Now, I'll get into that in the future. Now, the pi over 6 meters, 0.523599, that's said to be the exact Royal Egyptian cubit used to define the Great Pyramid. But what you'll find is, and so often you'll see, they'll say that the Great Pyramid is exactly 756 feet at the base. No, it's not. It's not 756 feet exactly on either side, and each side of a pyramid has a slightly different length, and not one of them has a length of 440 times pi over 6 meters. So this is very, very close. It's a hair, a fraction of a hair away in some cases. So this has a very, very close approximate. So the 1 meter, the pendulum swing, creating a 1 second, as we 86,400 seconds per day, that being 0.5236 almost meters. We're just rounding it off slightly, giving us a very good approximate of the Egyptian royal cubit. And of course that 30 degrees corresponding to the location of Heliopolis, as well as the Great Pyramid itself. There's a little bit to say, so it's at 29.9 degrees, but again, because of other the atmosphere and these other features that happen surrounding that, it essentially is at the observable at 30 degrees north. And of course those 3 pyramids, as a recent survey has shown, are aligned to Heliopolis, whether that's intentional or by accident. I would say, given everything else, that this has to be intentional for so many reasons. However, that also brings us back to Greenwich, the meter of the time being the pendulum swing being 86,400 seconds per day at Greenwich. As you can see, it changes slightly as we move away from the equator. So at the equator, 86,256 at Greenwich, which is 51 degrees, 28 minutes, 40 seconds. That's 86,400, which sort of joins the cubit, the meter, and the second. Also, there are other examples of it, but for instance, at the Red Pyramid, where we have this pyramidion, which was reconstructed 1 meter high, pi over 2 meters wide. Another nice connection. Of course, I've covered it earlier, but this has since been under the I use the word care of Zoe Hawass and his team. It was reconstructed and basically vandalized, for want of a better term. So we have these connections now. The Great Pyramid. So if I stand at the northeast corner of the Great Pyramid, and I'm including the sockets, so at the corner of these pyramids there was like these sockets reinforcing the corners, and if you include those to the base, and if you also include the socle, so the paving stones on which the Great Pyramid sits, which add just over 50 centimeters, half a meter to the height. So if you have the whole pyramid, so the paving stones plus the sockets at the corner, so there we have the measures, and if we multiply them by 86,400 seconds per day, time, and the meter, well, then we get some beautiful connections. So the rotational speed of the Earth, if you stand at the northeast corner, that's how fast the Earth is spinning per second. Up to such a high degree of accuracy, it's virtually indistinguishable from the best modern measurements. If you multiply the base of the pyramid, including the sockets, which is important, we get the equatorial circumference of the Earth, and that's from one angle. So that's an important feature. The pyramid is three-dimensional there. Now the 43,200 version, it's inelegant because it requires two views, and each view is using a subjective measure of it. But if I stand here at the corner from this one observation of a three-dimensional object, rather than looking at as two photographs on a piece of, or two pieces of paper, the top and the sides, what we get is a much more elegant system, and it describes the whole Earth rather than the half Earth, and it doesn't require any gymnastics like top view and side view. Sometimes, yeah. But that also, so of course, if you include the paving stones, the height of the Great Pyramid times 86,400, we get the polar diameter of the Earth. So we're not only describing the circumference of the Earth, we're also describing the polar diameter. So the Earth is not a perfect sphere, it's flattened at the top. And this is a very important in respect to navigation. If you don't quite get that right, then your navigation is going to be off. And so this is why it's very important, because time and navigation, 86,400 seconds per day. That, of course, incorporating the pendulum and the cubit and the meter and 86,400. So, which brings us to Greenwich as well, which is located essentially at the position where the Great Pyramid would point it to. So is London, Greenwich especially, more important than just an arbitrary position because of the English Empire, or is there something more to this? I would, I tend to lean on the side of skeptics without data, but I still think it's an important question to pose. I'm not saying that it is. However, with this information, yeah, a little bit either way. But again, you have to be careful, because if you have a confirmation bias, you can it leads to all sorts of really wacky ideas, such as the Apache helicopters and that type of stuff at Abydos. And so again, you need to retain a bit of skepticism, use the Socratic method, and keep asking questions rather than look for an answer that you want. But as a method, this one 86,400, because of so many reasons, the meter, the second, the cubit, all comes together at this scale. It describes a whole Earth rather than a half Earth. Again, so if you're navigating, you're not navigating a half a sphere, you're navigating a whole sphere, and so it's just more elegant. And so, just as an example of this, how these numbers and these measurements, blend into so many other beautiful aspects in regards to the clock and the compass as well. Which brings us back to Marulan here in Australia, in the Meridian Arch in Meridian Park, incorporating the sundial, of course, and its location, 150 degrees. So, for instance, it's 30 degrees so just like that 30-degree pendulum, Marulan, this important town for timekeeping, Australian Eastern Standard Time is defined here at Marulan, but but also its location is significant for those reasons. But also the numbers incorporated in there. So, for instance, 30 degrees, which would give you exactly pi over 6 meters we see there, 33.33 gradient, and these lovely numbers of especially 108,000 seconds. But also, since it's 150 degrees the other way to Greenwich, we also get, well, again, 54, sort of, again, lovely numbers there as well. And that's so close to phi plus 1, 2.618. Very lovely connections there as well. But also to go in the other direction back to Greenwich, that would be 210 degrees again. These are the perfect numbers in regards to pentagrams and phi. 756,000 seconds, 210 degrees, 756,000 seconds. The mean diameter of the sun, 756,000 Egyptian royal miles, and even at radian, 366.519. Well, if you're into your numbers, and especially 273 and how this 366, again, just it all blends with all these other ancient sites. And so the 30 degrees from Anti-Meridian, the Marulan Arch, and of course 30 degrees of the Great Pyramid, the pendulum, the second, the meter, Marulan being a perfect timekeeping town. It's probably the most perfect timekeeping town on the top of the list, or the most, even though it's a small town. People just drive past it on Hume Highway. It's not a grand monument, but the significance of the monument there cannot be really underestimated. And so again, this 86,400, the meter, the pendulum, the second, timekeeping, Greenwich, Great Pyramid, all comes back to the same lovely set of symphony of coincidence. And so this will be it. Now we'll follow up. I'm going to do some other videos because the Royal Egyptian cubit. So for instance, like there I have a 1 meter radius circle, which would make 12 Egyptian cubits on the outside. If we have a 1 meter diameter, we have the same thing. So pi over 6, 0.523599 meters, one Egyptian royal cubit. But is the Royal Egyptian cubit exactly pi over 6 meters? Well, if you look at the survey data and don't round off the numbers and use the most accurate that you can, not only does it incorporate, well, for instance, going back to the size of the Earth in regards to the pyramid, the northeast corner, so we have to, using exact measurements, not rounded ones off and not excluding features, what we get is not only a more elegant but a very, very accurate way of doing it, because each side of a pyramid has a slightly different measure, and therefore the base of the Great Pyramid cannot be 440 Egyptian royal cubits because each side is different, and at pi over 6 meters, even on the southern face, 756.072 feet, does not make it divided by 440. You do not get this exact meter. It's very close. We're splitting hairs, but in these small variations, there is some very profound information connecting to many other elegant things, joining ancient temple sites, ancient civilizations across the world together, and this is also encoded in modern sites. Now, for instance, Marulan, I mentioned strong connection to, for instance, Freemasons there, and earlier I mentioned Governor Macquarie and these other, well, especially here in Australia, strong connection to these people who were doing the survey, the architecture, the street plans, and it's all very esoteric, very in the Hermetic tradition, which of course Hermes, bringing us back to Greenwich, Hermes, weights and measures, Thoth, the same thing. Hermes Trismegistus is essentially, it's a fusion of these characters, and of course time and navigation, Hermes being the god of travelers and of commerce. Traders need to navigate, cross land, across sea, and bringing us back to geometry and just again the quadrivium, the Hermetic schools, and that these places which would be looked at as of no significance apart from being an arbitrary site of observations and measurement, well, there seems to be a lot more to it, and given these connections, the organisations, the groups, and it's not just about grand monuments. There also this little copper, it's about a centimetre wide. You wouldn't even notice it unless you knew what you were really looking for. Well, these things are actually very, very important. It's Hermeticism in its perfection. You don't need a grand temple. You don't need a grand Capitol building. The Hermetic schools, the tradition is about knowledge, not about grandeur. And this little plug is a perfect example of Hermeticism, where it's, you won't see it unless you understand it, but if you have eyes to see, you will see that there is, some really, really lovely stuff going on here. And with that, hope you enjoyed and have a good one. This is all connected. Cheers.